On September 11th, 2025, astronomers detected an extraordinary event that has captured worldwide attention. NASA's Solar and Heliospheric Observatory, better known as SOHO, recorded a brilliant green comet cutting through the ultraviolet haze near the Sun. The object, now officially designated C/2025-R2 and nicknamed SWAN after the instrument that revealed it, appeared with a tail spanning an astonishing 2.5 degrees across the sky, equivalent to 5 full moons lined up side by side. Only weeks earlier, another rare visitor had entered the solar system from the opposite side of the sky. Known as 3I/Atlas, it became only the third confirmed interstellar object ever observed. What stood out immediately was its unusual chemistry. Instead of releasing water vapor, like most comets, Atlas emitted bursts of pure nickel vapor, behavior that some scientists compared to thruster exhaust. Now, these two objects are racing toward the Sun, their orbits converging within just 7 days of one another. According to calculations from NASA's Jet Propulsion Laboratory, the chance of such a coincidence happening by gravity alone is less than 1 in a trillion. To illustrate the improbability, researchers have compared it to two ships leaving distant ports without navigation systems, only to arrive in the same harbor at the same hour. This convergence has sparked intense debate. Is it a natural alignment, or does it suggest something more deliberate? The discovery of SWAN began in an unlikely place. On September 11, 2025, amateur astronomer Vladimir Bezugly was reviewing archived SOHO data from his home in Eastern Europe. Launched in 1995, SOHO is a joint NASA-ESA mission stationed 1 million miles sunward, designed to monitor solar activity. Its SWAN instrument, short for Solar Wind Anisotropies, is built to map solar wind in ultraviolet light, not to find comets. Yet that is exactly what Bezugly stumbled upon. He noticed a faint streak crossing the ultraviolet haze, a nucleus with a wide fanning tail. Within hours, professional astronomers confirmed the sighting, and by September 13th, the International Astronomical Union officially named it C/2025-R2, SWAN. SWAN's brightness made it immediately accessible. At discovery, it registered magnitude 7.4, easily visible through binoculars. Observers from Chile's Atacama Desert to South Africa's Karoo quickly posted images online showing a vivid green slash across the constellation Virgo. Physically, SWAN is impressive. Its nucleus is about 10 kilometers wide. Its coma, an envelope of gas and dust, stretches 50,000 kilometers across, and its tail extends 2.5 degrees of sky. The distinctive green glow comes from diatomic carbon molecules excited by ultraviolet light from the Sun. On September 12th, SWAN reached perihelion, passing within 75 million kilometers from the Sun. Instead of fragmenting, it remained remarkably stable. Its tail stayed rigid, and its plasma appeared to deflect solar wind, almost like a protective barrier. 2 weeks later, on September 26th, SWAN erupted in a dramatic outburst, doubling in brightness to magnitude 5.9. The material it expelled soon interacted with Earth's magnetic field, triggering widespread auroras that glowed in the same green as the comet itself. From Alaska to Australia, the skies lit up. Astronomers noted SWAN's unusual resilience. At surface temperatures above 1000 Kelvin, most comets disintegrate. SWAN held together, prompting speculation online that it behaved less like a fragile ice ball and more like an armored object. NASA even featured a striking SOHO image of the green halo in its astronomy picture of the day. Between October 12th and 19th, Swan will make its closest approach to Earth. If it continues to brighten, it could become visible to the naked eye. The other half of this celestial pairing was first detected on July 1, 2025, at dawn in Chile's high desert. NASA's ATLAS survey, a system designed to identify asteroids that might threaten Earth, spotted a faint anomaly at magnitude 18. The Minor Planet Catalog categorized it as C/2025 N1, Atlas. Its hyperbolic trajectory soon confirmed it was not bound to the Sun. This was an interstellar object, only the third ever found, following Oumuamua in 2017 and Borisov in 2019. Spectral analysis from the European Southern Observatory's Very Large Telescope revealed unusual chemistry. The coma was dominated by nickel vapor, with almost no trace of iron. On Earth and in most comets, nickel and iron occur together, forged in supernovae. Finding nickel without iron is like discovering a pure gold vein untouched by surrounding minerals. Even more unusual were its emissions. Instead of water vapor, Atlas released carbon dioxide at 5 times the expected rate, a ratio seen in less than 1% of comets. And then came the most puzzling behavior. 3 sudden bursts of acceleration, each releasing energy equivalent to 10 nuclear power plants. Each event shifted the comet's tail from red to green, as though a thruster had fired. Some researchers suggested the phenomenon could represent thrust modulation, a term used in spacecraft engineering. Harvard astronomer Avi Loeb described it as part of a possible technosignature cascade, meaning a series of behaviors that might point to artificial origins. Others advised caution, arguing that exotic outgassing might still explain the data. Online forums quickly filled with debate over whether Atlas was natural or engineered. Atlas reaches perihelion on October 5th, passing within 50 million kilometers from the Sun, closer to our star than Mars ever comes to Earth. Taken individually, both Swan and Atlas are remarkable, but together they represent something astronomers have never seen before. Swan approaches from Aquarius, its orbit tilted 60 degrees relative to the plane of the planets. Atlas plunges in nearly perpendicular from Sagittarius. Despite their radically different origins, both reach perihelion within 1 week of one another, at almost identical distances from the Sun. Simulations from NASA's Jet Propulsion Laboratory show the probability of this occurring by chance is less than 1 in a trillion. To scientists, it is an alignment that stretches the limits of coincidence. And just as they converge, observation will become impossible. Between October 8th and 18th, the Sun's glare will overwhelm telescopes, blinding SOHO, Hubble, and the James Webb Telescope. For 9 days, astronomers will be unable to collect detailed data, precisely during the period when both objects are closest to the Sun and closest to each other. The timing has raised questions. If these objects are artificial, this blackout would provide ideal cover for interaction, whether docking, data exchange, or something else. Amateur astronomers worldwide are already mobilizing to fill the gap. Veteran tracker Bill Gray urged observers to keep watch, saying, "We've got the eyes to fill the gaps. Anyone with a scope can join." But even coordinated backyard efforts will not fully replace the data lost during those 9 days. These modern mysteries carry echoes of ancient history. Swan follows a vast elliptical orbit lasting more than 22,500 years. Its last passage through the inner solar system occurred around 20,000 BCE, during the peak of the last glacial maximum, when ice sheets 2 miles thick blanketed the northern hemisphere. Greenland ice cores from that era contain spikes of nickel, cobalt, and iridium, elements tied to cosmic impacts, rather than volcanic eruptions. Archaeological evidence adds to the intrigue. At Göbekli Tepe, a 12,000-year-old site in Turkey, massive stone pillars feature carvings that some researchers interpret as astronomical records. Certain motifs appear to track solar cycles, while one fox carving has been linked to a comet swarm around 10,850 BCE.